Hey guys, last part of chapter 4 that we're going to cover are the counting rules. We're going to learn specifically two counting rules. This will be the last stuff that we cover prior to the review, and in the review we'll just go over all of it. Okay? So the two counting rules is the multi-step rule and the combinations rule. Multi-step, if an experiment can be described as a sequence of k steps, in which there are n1 possible outcomes for the first step, n2 for the second step, and so on and so forth, all the way up to nk. The way that we would count the experimental outcomes for that would just be the product, would just be n1 times n2 all the way up to nk. Okay, if that sounds math jargony, I think it'll become more clear with the example. So yeah, I guess don't worry if you don't understand just based upon that. We'll get into it in the example, and I think it'll just become very, very clear as to what that means. Then the second counting rule is that for combinations, and this is the number of combinations of n items that can be selected from large n items, and that's denoted with this formula. Another way to write this, and what you might see in your calculator, this is also written as how do we do it? Is it n choose n? Okay, and so that would just mean you have a large number of items that you're selecting from, and then little n is the number that you select from that. And then this is the formula to determine how many different combinations of little n items there can be. So if you haven't seen this in a while, or if you don't know, so this right here is not a fraction. This is just the same notation as this, or I guess different notation for the same concept. So this would be n choose n, and this would also be n choose n. And this formula is big N factorial. So I don't know if you recall what factorials are, but a factorial, so like x factorial, would be x times x minus 1 times x minus 2 all the way down to 3 times 2 times 1. Okay, so it's whatever the number is times each, so 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So this is what that factorial means. So big N factorial would just be the larger number of the group. Small n factorial would be the amount that you're choosing. And yeah, this is the formula. We'll show you how it works. So why don't you turn over to number 4 on your worksheet. And we'll just get started. So this first one is going to have to do with the multi-step rule. Rule. Fantastic writing there. A credit union has 2 branches. Each branch has 2 departments, and each department has 4 employees. How many total people does the credit union employ? Okay, so if you work for the credit union and one employee is randomly selected to go to the convention, what is the probability that you will be chosen? Okay, so first thing, let's just use the formula. So we'll go back to the slide, and this formula is n1 times n2 all the way up to nk. Okay, and these are just the different branches. So we look here. So these are the different steps, sorry. So we have 2 branches, so we can consider that N1, 2 departments, N2, and each department has 4 employees, so 4 employees. 2 times 2 times 4 is 16, so 16 employees. To visualize that, so we could say the credit union, and this would be a this will be a branch. So we'll say branch 1, branch 2. Each branch has 2 departments. So Department 1, Department 2. I guess we'll call this Department 3, Department 4, and then each department has 4 employees. All right, that's a terrible drawing, but I think you get the point. So we would have E1, E2, E3, E4, E5, all the way down to E16. So that would be 16 employees. And that's just, I guess that's how you would visualize it. I'm sure you'll draw a better version of that when you're taking notes. Okay, and so then lastly, if you work for the credit union and one employee is randomly selected to go to the convention, note, randomly selected, what is the probability that you will be chosen if you are one of those employees? And this harkens back to, I think it was 4.2 or 4.3, the rule about all of the sample space outcomes being equally likely. So given that all of the sample space outcomes are equally likely, we just, we pick out the number of sample space outcomes that are in the event. The event is us being chosen, so we're one employee, and then just over the total number of sample space outcomes, 16. So that's the probability of us being selected. 1 in 16, or I think that's 0.6666666. So yeah, we'll just say 1 in 16, just because I'm not sure about that decimal. So yeah, that's that. So that's the multi-step rule, and then we'll get on to the combination rule. Number 5, a small company has 20 employees. 6 of these employees will be selected randomly to be interviewed as part of an employee satisfaction program. How many different groups or groupings of 6 can be selected from the 20 employees? So this, we know, is we have 20 total employees, it's 0, 20, and we're selecting 6. Okay, so we can have big N, C, N, or N, choose N. These are both going to equal 20, choose 6. They're the same thing, 20, choose 6, which we know is 20 factorial over 6 factorial times 20 minus 6 factorial, which is equal to 20 factorial, 6 factorial, 14 factorial, and we're going to expand this out a little bit. 20 factorial, 6 factorial, 14 factorial is equal to 20 factorial, 20 times 19 times 18 times 17 times 16 times 15 times so on. Okay, but we know that so on gets to 14, and we could just call that 14 factorial, right? So we would have 20 times 19 times 18 times 16 times, and then we could just call that 14 times 13 times 12 times 11 all the way down 14 factorial. See where I'm going here? And then 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1 times 14 factorial. And now we can factor that out, and we just get it's 20 times 19 times 18 times 17 times 16 times 15 all over 6 times 5 times 4 times 3 times 2 times 1. And if we did all of the math, we would get 38,760. So I'm going to go ahead and show you just how to do this very, very simply in Excel. Excel function equals combin, the number and the number chosen. The number would be the 20. The number chosen would be the 6. And 38,760. Alright guys, so that includes the lecture for Chapter 4. Check out the review. That should be posted shortly as well. But please let me know if you have any questions on this material in the discussion. Again, all of the important stuff that's in Chapter 4, well, I guess it's everything except for Bayes' theorem, unless you really want to use Bayes' theorem. As I've mentioned a million times, I suggest using contingency tables. But yeah, stay tuned for the review, and we will have more of me going over the review. All right, thanks so much for listening, guys, and take care.